All right, today we're going to pull back the curtain on a high-stakes digital heist. But forget safe cracking and getaway cars. We're talking about a few sneaky lines of code that can take down entire companies. We're breaking down one of the most common and most dangerous cyber attacks out there, the SQL injection. Let's dive in.
So just to give you an idea of the scale we're talking about, look at this number, 94,057. You know what that is? That's how many SQL injection attack requests a single website got hit with in just one day. Yeah, this isn't some rare, super sophisticated thing. It's a constant, automated flood of attacks happening all over the internet right now.
So what are these hackers even trying to get into? Well, you can think of them as our digital treasure vaults. See, in the modern world, pretty much all of an organization's most valuable stuff, all its data, is locked away inside databases. And what's actually in these vaults? We're not talking about abstract numbers here. We're talking about literally everything. Corporate financials, secret product designs, but most importantly, personal information. We mean your name, your social security number, your bank account details, maybe even your private health records. It's all in there, which makes these databases a massive, irresistible target for bad actors. Now, the specific kind of vault we're talking about is called a relational database. Sounds technical, right? But don't worry, the concept is actually pretty simple. Just think of it like a bunch of super organized, interconnected spreadsheets. You've got one table for customer names, another for orders, and they're all linked together. It's an incredibly efficient way to store and find huge amounts of information. So, every vault needs a key, right? There has to be a way to open the door and ask for what's inside. For these databases, that universal key is a special language called SQL. SQL, which stands for Structured Query Language, is basically the official language of databases. It's the translator between us and the data. So anytime you search for a product on Amazon or log into your online bank, there's an application in the background using SQL to send commands. You know, like, hey, database, find me this user, or show me all the shoes in size 10. And here's the catch. As this quote points out, SQL is an incredibly powerful and complex language. That's what makes it so useful. But that very same complexity can be turned against it. It's like a precision tool that, in the wrong hands, can be used to dismantle the entire system it was built to manage.
So how does a hacker actually turn this universal key into a lockpick? This is the heart of the digital heist. And honestly, it's a brilliantly simple trick that takes advantage of a really common mistake in how websites are built.
Okay, let's start with a normal, everyday request. Let's say you're on a website and you type Redmond into a search box to find all the orders from that city. The website takes what you typed and builds this perfectly normal SQL query. It's basically asking the database, select everything from the orders table where the shipping city is Redmond. Totally simple, totally safe. But what if instead of a city, the attacker types this into that same search box? At first glance, it just looks like a mess. But to a database, this isn't just data. It's a whole new set of commands. The attacker isn't just giving a city name, they are injecting a second destructive instruction right into that input field.
And this is where it all goes wrong. If the website is poorly designed, it just takes the user's input and glues it directly onto its SQLer command. That tiny semicolon is a signal to the database that says, okay, first command over, here's a brand new one. And that new command? Drop table orders table. You know what that means? It means delete the entire orders table. And that double dash at the end? That's a comment telling the database to ignore whatever comes after it. And just like that, the vault has been emptied.
And get this, attackers aren't just using website forms. They can inject these malicious commands through all sorts of backdoors. They can mess with the data stored in your browser's cookies, those little text files websites use to remember you. They can even do it through physical things, like a manipulated barcode at a self-checkout scanner. The main point is, any place a system takes in outside information could potentially be a way into the vault.
Okay, so that's pretty terrifying. The vault is vulnerable, the lockpick is way too simple. So how do we fight back? How do we fortify the database and actually build a better security system?
Well, the good news is security experts have a multi-layered game plan. It all starts with the most important step, just writing secure code in the first place. But on top of that, you can add detection systems that are always watching for suspicious activity, and even tools that can step in and block a malicious query before it ever runs.
So let's focus on that first step, because this right here is the fix.
On the left, you see the insecure code that just blindly glues text together. But on the right, the secure code uses something called parameterized queries. This is a total game changer. It creates a firewall separating the command from the data. The application basically tells the database, hey, here is the command template, and over here is the user's input. And no matter what is in that input, I want you to treat it only as data. Never, ever run it as a command. Just like that, the lockpick doesn't fit in the lock anymore.
So, we have these powerful defenses, which is great, but how does all this work in the modern world? See, today, most of these digital vaults don't live in a server room down the hall anymore. They live in the cloud, and that changes the security game completely.
Now, this is the official, kinda wordy definition of cloud computing. But what it really means is that organizations are just renting computing power, storage, and all kinds of services from huge providers like Amazon or Google over the internet. And this one shift changes everything about how we have to think about security.
And not all clouds are created equal. A company might use a public cloud, sharing the actual hardware with lots of other customers. Or if they need more control, they might build their own private cloud. A lot of companies use a hybrid model, mixing and matching. Each one of these choices fundamentally changes who holds the keys to the vault and who's responsible for keeping it safe. Okay, this chart is absolutely critical to understanding cloud security. It's called the shared responsibility model. Think of it like renting an apartment. The landlord is responsible for the security of the main building, but you are responsible for locking the door to your own apartment. It's the exact same idea in the cloud. Depending on what kind of service you're buying, the security duties get split up. But here's the key takeaway. The cloud provider always secures the physical building, but the customer is almost always responsible for their own data and who can get to it. One tiny mistake on their part can leave the vault door wide open.
And because of this shared model, new kinds of risks pop up that go way beyond a simple SQL injection. Now, attackers might go after insecure APIs. Think of those as the digital doorways between all the different cloud services. Or they might try to hijack an entire account, which is like stealing the master key to the whole apartment building, not just one unit. The heist in the cloud can be way more complex, with even bigger consequences.
So, the single most important thing to remember is this. When a company moves its data to the cloud, it gives up some direct control over the hardware, but it can never, ever give up accountability for the data. Protecting that digital vault becomes this crucial, ongoing partnership between the company and its cloud provider. Which really leaves us with this one final critical question. As more and more of our personal and corporate vaults move into the sky, who is ultimately watching the door? Is it the company that you're trusting with your data? Is it their giant cloud provider? Or, in this new world, does some of that responsibility now fall on you?